I want to build a custom table for our new home and use the same reclaimed lumber that we used in the barn roof and the well house, and also some lumber that we used in the windowsills in the house. Here we are selecting the boards. I found one in my shop, but the rest I had to pull out of a pile that's been sitting outside through 2 monsoon seasons.
That looks like oak.
That looks like oak too. Darn it. Is that everything?
Oh, the one under that one.
Yeah, these two I'm almost positive are ash. This one is definitely ash.
So you found 2 ash?
Yeah, and I need 3. Character boards. Good for a tabletop. Any holes or anything I can hold. Okay, here's the tabletop. These are the boards that we finally selected to use for the tabletop. I had originally wanted to use ash since I had a few good ones saved away in my shop, and all of the oak boards that we had were pretty rough. But we didn't have enough ash, and so I ended up deciding to use all oak boards instead. They're quite rough and will need a lot of work. These boards are a species of oak that is an unusual species called live oak. It's a tree that's common in the Southwest, but not used commercially, generally speaking, but it's a really cool tree. They have evergreen leaves, and that's why they call it a live oak, is because they always look alive. And it has some really interesting characteristics. The wood is about twice as hard as regular oak and extremely tough, even tougher than like hickory. So it's an extremely tough, hard, gnarly wood, and it'll be really interesting to work. These rough cut boards are about 10 feet long, 2 inches thick, and 5.5 to 6 inches wide. So I'm about to cut off the excess here and trim them a little bit closer to the finished length, which will be 8 feet. This wood is reclaimed lumber, and it didn't start out life as A-grade commercial quality wood. It's definitely a B-grade wood, and it's had a long, difficult life. It's sat out in the sun and the wind and the rain for years, and so it is in pretty rough shape. It is cracked, it is warped, it is twisted, and it's going to need a lot of processing to turn it into a nice finished table. I'm using a couple of winding sticks and a very long level that's perfectly flat to help me out with this. The winding sticks help me get the twist out of the large flat side, and the level helps me get the edge straight. These boards are warped enough, twisted enough, and cupped enough that they need a considerable amount of work before they can even be put into a mechanical planer to take down to dimension. So I'm using a hand planer here, and I'm just trying to take off the cupping, the warping. I'm trying to get one flat side and one flat edge. Now I'm putting the boards through my old Craftsman planer to get to a rough dimension. It is really working this planer hard. This wood is so tough. I'm having to really pull and push the boards through. This planer is also on its last leg. It's near the end of its useful life. I've had many good years of service out of it, but just about everything is about to die on it. Bearings, bushings, and I'm hoping I can get these boards roughed out as its kind of final last act of service for me. Well, the Craftsman made it through the roughing in process, but it literally died at the end. It started smoking, and I had to set it aside in the dirt so it wouldn't catch something else on fire. So it served me well, but it's totally done. You can see it sitting off to the side there. This side may be the best side. The other side, that's nice too, but just got a lot of color, darker heart kind of. That side is good. I've now brought out my newer Makita planer to take these boards to finished dimension, which will be 1.5 inches thick. These boards were just rough cut to thickness, and they varied between 1.75 and 2.25 inches thick, so it took a lot of passes. It's also really hard, so I had to take a lot of light cuts. For the next step, I had to break out one of my favorite tools. This is a number 22 Miller Falls jointing plane, and the attachment I'm using is a fence. Here I'm about to mark the board with a pencil so that I'll be able to see where the plane has cut as I go along. I'm going to use the plane and the fence to square off and straighten the edges of these boards so that I can join them all together to make a tabletop with no cracks in between the boards. These boards are really long and really heavy. They're 8 feet long, 1.5 inches thick of super dense live oak, and so they're way too heavy to put through my little powered jointer. And so I had two options. I could either go out and buy a $5,000 or $10,000 huge jointer, which of course isn't practical, or I can pull out this wonderful old antique tool and do it the manual way. 100 years old, literally 100 years old. And it's still the best option. It's pretty weird. Unless you have a big, expensive machine, but machines are great. I'd love to have one. This old plane is huge. It's about 22 inches long, and it's quite heavy. And the length of the plane helps it to make a perfectly flat and even surface. And the fence on the side allows me to keep the edge square with the other surfaces. I'm using a freshly sharpened blade on this wood, and it's still all I can do to move the plane along the surface of this wood. The wood is just so hard that it resists cutting, and I can do it, but just barely. It is quite a workout. This was a fairly slow and laborious process. I did it over the course of 2 days and about 4 sessions, totaling up to about 6 hours total. I had to break it up because it was so physically demanding that I just needed long breaks in between. My shoulders could only take so much. I've done a fair amount of planing on different hardwoods, cherry, walnut, ash, and this live oak is several times harder than anything else I've ever tried to plane. That's why it's so difficult. I'm putting all my body weight to take a light cut with a sharp edge. Getting close. Okay, that's probably close enough. Checking, and actually this is not completely straight. This is the first one I've had any trouble with that. It's catching on the end. It's literally kind of what's happening is the wood is just fighting you. After the edges were all square and true, I was ready to use a biscuit joiner to cut in 5 biscuit joints on each seam. That'll add a lot of extra strength to each seam. Here I'm getting my table all leveled, taking the twist out, and getting ready for the glue up. Well, it's glue up day. I have all the boards brought outside, I have them on my table, and I'm getting everything set up and getting ready for the big moment. It's always incredibly nerve-wracking to do a glue up on a project like this. I'm going to try to do the glue up all at one time. It's a cold morning, and we had to bring the boards outside and let them sit in the sun a little bit to warm up. You don't want them to be too cold when you apply the glue. There's no way I could apply the glue fast enough myself, so I'm enlisting April's help. I'm giving her some instructions here, and we're talking about the sequence of operations that'll need to happen in order to make this all work out right. Here we are applying the glue. This is the stressful bit, even with both of us working as fast as we could to get the glue on and get those biscuits in. It was really hard to do before the glue started to dry a little bit, so we're working against the clock to apply this glue. We ended up using over 1 whole container of glue in this glue up, so it's a lot of glue to get on and a lot of surface to cover. But we got the glue on and now we're clamping it up. As you can see here, in addition to the clamps, I'm using 3 sets of 2x4s that I'm bolting together with bolts that go all the way through. Those boards are there to keep the tabletop from warping during the drying process. It'll keep it nice and flat and straight, and the clamps are there to hold it all together tight. So that one's okay. It's just these. Basically should be 30 and a half. So 35 and a half. Now I'm moving on to the base of the table. You can see the rough wood that we used here. It's also live oak. It's a secondary quality live oak that came from a set of bunk beds that we purchased for almost for free, just for the raw material. So it's salvage material, and we use the same material for the windowsills in the house, and so it's cool to be able to use it as the base of the table here. The tabletop has been drying all day. It's getting close to evening, the sun is starting to set, and it's getting cold outside. And so we needed to remove the clamps and take the table inside. The temperature outside is dropping and it'll soon be below freezing, and if we left this tabletop outside, it would ruin the piece. Glue has to be allowed to cure completely before it's allowed to get below about 40 degrees. And it actually says on the bottle of glue how low you can let the temperature get. It's above freezing. I forget the exact amount, around 43 degrees or something along those lines. And you can't let it get 1 degree below that. It has to remain above that. Otherwise, it'll turn to powder and your piece will be ruined. So it's critical that you don't let your piece get below that temperature until it's completely cured. I've already ran these base pieces through the planer, and so I have them dimensioned to thickness, and now I'm cutting them to length. These pieces cleaned up to a dimension of about 3 1/4 by 3 1/4, so it's very thick, very heavy duty. Each board is comprised of a laminate of about 5 or 6 pieces of 3/4 inch thick oak to create that 3 1/4 inch thickness. I'm building this base using mortise and tenon joinery, and I'm using my table saw to cut the tenons. This is definitely a very dangerous step, especially the way I'm doing it freehand here. I've done a lot of this and I'm confident in the way I'm doing it, but I definitely wouldn't recommend it to the novice woodworker. At first I tried just putting 2 old blades together to increase the thickness of the cut on each pass, but it was really hard on my table saw and wasn't working too well, so I ended up making a trip to the store and getting a purpose-made blade that really helped out a lot. It's not powered down, but it is on.
Yeah.
I've cut many tenons by hand in the past, just using a saw and chisel, but it's really labor intensive and this is saving me a ton of time. I'll still have to cut the mortices by hand using a chisel. And now I'm moving on to the mortices, just taking out as much material as I can using different sizes of drill bits and then finishing up and squaring everything out with the chisel. I used a marking tool to mark out the border of the mortise, and then I just followed that border that I marked with a chisel. I like using a chisel that has a end plate that I can strike with a hammer. There's different types of chisels. Some are made to push by hand and they don't have a place on the butt of the chisel that you can strike. But I end up, using a fair amount of force, especially going through this type of thick, hard wood. And so I needed a chisel that you can really hit hard with a steel hammer and get a real sharp impact. And so I just have a set of old Craftsman chisels that I use for this, and they're perfect. Another thing that was nice about doing these mortises is the tenons are all very close to the same size. Since I did them all on a machine, they're very consistent in size, and so I can just make all these mortises to the same size as well. I don't have to try to custom make each mortise to each tenon. That at least gets me close. It works for the general shaping. However, I do go back over it and do a little bit of fine tuning because I like as close a fit as possible for each tenon. So, for each tenon I make sure it fits perfectly, and then I mark them so that I know which mortise goes with each tenon. It's interesting the tolerances that woodworkers use when you're making a mortise and tenon like this. You're actually working in the thousandths of an inch to get a really precise fit like this, where it just barely goes down with a little wiggling and tapping. It's amazing how close it has to be in order to get those really tight fits. I used to be a machinist, and so I'm used to working in thousandths of an inch tolerance. And in fact, one of the tools that I use when working with wood is a dial caliper, which allows you to measure in thousandths of an inch. And it's just funny that you use that same measuring tool for use with wood or metal. So these come in and out. This workbench is one that I built several years ago, and it is so nice for doing this type of woodworking. It has a special vise called a tail vise that allows me to grip wood that's sitting on the surface of the table. I've got the pieces for the table base ends all made, and now I need to create the cross piece that'll tie both ends of the table base together. I'm going to be using a modified dovetail joint to make that connection. This is a custom joint that lends itself well to hand tools, so I'm having fun here using a saw and chisels to create this connection. I've just drawn out a dovetail shape on the top here. It doesn't matter exactly the angles, just choose whatever angles you like to make a nice dovetail shape, and then cut it out as precisely as you can. It's important that the edges are straight and that you end up with a nice shape. I'll be transferring this shape onto the end pieces once this is all nice and cleaned up. I'm only making the dovetail part about 1.25 inches thick. Now I'm creating the other part of the connection, the slot that will receive that dovetail joint, and I'll be using mostly power tools and a chisel for this. I began here by transferring the marking from the crosspiece dovetail onto this end piece. I just laid the top piece on and using a pencil transferred the mark. Once that mark was there, I followed it as closely as I could with the handsaw. I felt like I could get close enough with the handsaw that I would just barely have to come in and touch up with the chisel. Once I hogged the material out of the center, I wanted to get the flat portion all smoothed out, the base of the dovetail groove, and so I used a router to do that. That worked really good. I was able to get a nice smooth surface. Then I just used a chisel to come back in, clean up the corners, and clean up the edges, get it to exactly the right width to follow that dovetail mark. And just doing a little test fit here to see how it fits. Really close. I could tell I needed just a little bit in a few places, so get out the chisel, take a few more thin shavings off, and I'm checking the squareness of the edges, making sure I'm maintaining squareness. Also, I find it's handy to use a file occasionally instead of a chisel for really fine bits that you need to take off. A file is really handy as well. And here I am making some final adjustments with the file and fitting it into place. Here next to my dovetail joint and in some other places you can see the remains of an old mortise and tenon joint that was used to hold the bunk bed together. Well, all the joinery is done. I've completed all my mortise and tenons and my dovetails, and I'm ready to move on to hardware. I want to be able to take the table apart in the future, and so instead of gluing together the mortise and tenon joints, I'm going to be bolting them together using lag bolts. Here I'm cutting a groove along the length of the threads along the side in order to turn them into self-tappers. I'm worried about them going into this really hard oak that I'm using, and I think this will give them an edge and help them to go in easier. The tabletop is now dry, so we've brought it back out and I'm starting to work on the surface. I discovered that it had warped and moved some, and the reason for that is the cracks that are in this old wood. This wood is old, it's full of cracks going up and down the length, and I think that's allowed it to move a little bit while it was drying, and so I've decided that I need to stabilize those cracks by adding some bow ties. In modern times, bow ties like these have become a decorative feature that wood enthusiasts like myself use to make pieces look nice, but what they started out being was a structural device that stabilized cracks and kept them from expanding or changing over time, and so they had a purely mechanical, utilitarian purpose originally, and that's what I'm doing here. I'm using these bow ties for a utilitarian purpose. So I'm just going through the piece and marking out where I need to add bow ties to strengthen the piece, to keep those cracks from extending, to keep the table from warping, to stabilize the structural integrity of the top. And so I've marked out the locations that need some help and where I'll be adding bow ties, and now I'm adding them. I like to start out by creating the bow tie itself. The particular shape and size isn't critical. As long as it's roughly bow tie shaped, it'll work. Then I bring it out and put a piece of tape on the piece and then draw an outline of the bow tie that I'm going to be using and then create the recession. I used a chisel to go around that trace mark that I created earlier and clean up the edges and make it fit perfectly the bow tie that I'm going to be using here. Once it fits real nice, I just put in some glue and then hammer it into place. At first I was thinking that I wouldn't need too many of these. I could get away with maybe 3 or 4 on each side, but the more I looked at the piece and really started to closely examine it, the more I ended up putting in. By the time I was done, I had put 9 bow ties on each side of the piece for a total of 18. I've done quite a few bow ties in the past, but the experience today really helped me refine my technique and get faster. I was able to do all 18 bow ties in one day. It was a long day, but I got it done by dark. And now moving back to the base, I just need to drill the holes for the lag bolt and also recess those holes so the bolt doesn't stick out above the surface of the wood, and then I'll be ready to assemble. With those holes all drilled, I'm ready to do a first test fit. I haven't even sanded things yet, so I'll have to take this apart later, but I want to put it together, put these end pieces together, and get the cross piece on so that I can start working on the diagonal supports. What I realized when I was putting this together is that I'd gone a couple pieces backwards. I wanted some of the showy features of the wood to be on the outside so that they were more visible, and when I put this together I realized that I had somehow messed up and I couldn't orient it in that direction, and it really frustrated me because I wasn't able to easily correct it, but it worked out in the end. We got to looking at it and decided that showier, more character part of the wood looked better on the inside anyway. There's a piece that you can see in the center of the cross piece hanging down there that I haven't mentioned yet. That is my pendulum brace that I'm going to connect my cross pieces to. And now I'm starting to size up those cross pieces, just looking at how they fit in. I've decided to attach these diagonal braces with metal brackets instead of using some kind of wooden joinery. I like to combine occasionally metal with wood. I think it creates a nice effect, and I think it'll look really neat to add some metal and bolts and brackets into this table base. I cut the cross brace pieces to size, and then I put large bevels on the ends of those pieces and on the pendulum brace here, and I'm getting ready to do some fit up and figure out the braces. I'll be using some 2-inch wide by 1/8 thick metal strap to create the connections between the pendulum and the diagonal brace arms. I enjoy working with metal as well, and so combining wood and metal is always fun. Here I'm working on these strapping pieces. I want to cut a couple bevels on the corner, and so I just mark those out. I'm cutting those off with a little die grinder, and then I'll come back and clean up those edges with my sander. I have a little, actually it's a decent sized dual sander that I use for that. After I had the bracket pieces all cut to size, I moved on to drilling the holes. I clamped the bracket sets for each side together and drilled them all at once, so the holes were all the same. Drilling through multiple sheets of metal like this is really hard on drill bits, and one drill bit I found that actually holds up to it is a DeWalt Cobalt drill bit. They're really amazing. They work great. I was able to cut through all of these plates, and the drill bit's still perfectly sharp. This isn't a paid advertisement, by the way. I just like the drill bits. These braces are almost finished up. I can't wait to see them on the cross pieces.
Good. Got these